Hey guys, here's section 6.2, day 3. I really just wanted to go over some more examples with you, so skip around to see the different kinds. I started with just some normal find the exact values of. I tried to focus on most of the reciprocals and some quadrantal angles, and then it's just going to run through some different types of examples you might see on the online homework. So like I said, skip around to the ones that you need to see. All right, if they asked you to find the exact value of the cosecant of 7 pi over 4, first we got to figure out where does 7 pi over 4 land. Well, remember your anchors. We got pi is halfway around, and then all the way around is 2 pi. So in the world of pi's over 4, that's 4 pi's over 4, and then it takes 8 pi's over 4 to get all the way around, right? That's 7 45-degree angles. So if we do that, it's going to rotate. If that's 8 pi over 4, 7 pi over 4 will land in the quadrant right before him. So there is 7 pi's over 4. Well, remember, 7 pi's over 4 won't fit inside of a right triangle, but the reference angle will. So the reference angle is 1 pi over 4. So what you're really finding is the cosecant of pi over 4, but it landed in quadrant 4. Okay, well, what is the cosecant of pi over 4? What is the cosecant of 45 degrees? Well, you can either whip up a special right triangle real quick, right? 45, 45, that's 1 to 1 to root 2. Now, if they asked you the cosecant, that's the reciprocal of sine. So the sine of 45 degrees, I'm going to go over off of this one, is O over H. But the cosecant is H over O. So that's root 2 over 1. So the cosecant of a 45-degree angle is root 2. But what is it, positive or negative if the angle landed in quadrant 4? Well, according to all students take calculus, only the cosine function gets you a positive ratio for an angle in quadrant 4. So that means that the cosecant, which is the reciprocal of sine and does the same thing that sines do, that's also going to be negative. Okay, so that's a negative root 2 is your ratio for the cosecant of 7 pi over 4. All right, well, what about the secant of 4 pi? Where do 4 pi's land? Well, this one should be a little bit easier in the sense that you already know if you make one complete rotation, that's 2 pi radians. So every 2 pi radians, you've gone a complete rotation from wherever you started. So if I go around again, now that's going to be 4 pi's. So 4 pi's land in the same spot as 2 pi's. So what ordered pair is that on your unit circle right there? That's 1 to the right, so that's 1, 0. Secant is the reciprocal of cosine. So the cosine is the x-coordinate. So the cosine of 4 pi is 1. So the secant of 4 pi is the reciprocal of 1. What's the reciprocal of 1? 1. All right, what's the cotangent of negative 5 pi? Well, where do negative 5 pi's land you? Well, if it's negative, you have to rotate clockwise. Now remember, every pi radians gets you halfway around. So that's 1 pi. Another pi gets you to 2 pi is all the way around. Another halfway is 3 pi, gets you another halfway. Another pi is negative 4 pi, I should say, gets you all the way around. And that means that negative 5 pi, if I go one more pi, one more halfway around, that's negative 5 pi's. So what ordered pair is that on the unit circle? 1 to the left is negative 1, 0. So the cotangent is the reciprocal of tangent. Tangent is the y-coordinate over the x-coordinate. So cotangent is going to be the x-coordinate over the y-coordinate. So negative 1 over 0 is undefined. So technically, that means that negative 5 pi is an angle that is not in the cotangent function's domain. That's an angle that you should not be plugging into him because you get an undefined ratio. And you learn more about the domains and ranges when we get to section 3. All right, what is the tangent of 11 pi's over 3? Well, where's 11 pi over 3? Well, I got my anchors. Pi is halfway, 2 pi is all the way. So in the world of pi's over 3, that's 3 pi over 3, and then that's 6 pi over 3. Every 3 pi over 3 radians gets me halfway around. So if I'm going for 11, that's more than one rotation. So let's see. So I've already made one rotation. I'm at 6 pi over 3 radians. If I go another halfway, another 3 pi over 3, that is 9 pi's over 3. Lands in the same spot as 3 pi over 3. So I got to keep going. If I go all the way around again, if I go all the way around again, that's another 3 pi over 3. So 9 pi over 3 plus 3 pi over 3, that's 12 pi's over 3. So that means that 11 pi's over 3 is going to fall in the quadrant right before him. So that means I have to rotate all the way to there and stop. I can't go all the way because that would be 12 pi over 3. So that's 11 pi's over 3. So obviously 11 pi's over 3 doesn't fit inside of a right triangle, but his reference angle will. So what you're really doing, his reference angle, which is 1 pi over 3, you're taking the tangent of pi over 3, but it landed in quadrant 4. Okay, well, what is the tangent of pi over 3? What is the tangent of a 60? Well, if you whip up a special right triangle, right, 60, 30, that's 1 to root 3 to 2. So if we're talking about a 60, the tangent of a 60 is O over A. O over A is root 3 over 1. So that would be root 3. Now, is it positive or negative? Well, all students take calculus says again that the cosine is the only function that gets you a positive ratio for angles in quadrant 4 because the x-coordinate is positive. So the cosine ratio is positive, but that means that the tangent ratio for an angle in quadrant 4 is negative because it would be a negative y over a positive x if it was in quadrant 4. So that's negative root 3. Okay, what is the cotangent of negative 15 pi over 2? Well, where does that land? Well, this one, pi over 2, if you think about it, 180 divided by 2, that's 90. So that's negative 15 90-degree angles. So I just start counting, and I got to rotate this way because it's negative. So this would be negative pi over 2. That's one negative 90-degree angle. And then another 90 degrees is there. So that's your second, your third, your fourth, your fifth, your sixth, your seventh, your eighth, your ninth, your 10th, your 11th, your 12th, your 13th, your 14th, your 15th is right there. And technically it's negative because we were rotating clockwise. So that is where, if you keep just, what do we do? 1, that got us what, 4 90s? Go around again, that would be 8, that would be around 12, and then 13, 14, 15. That's your negative 15 pi over 2. So what point is that on your unit circle? It's up 1, so that's the point 0, 1. So again, we're doing cotangent. Tangent would have been the y over the x. So cotangent is x over y. 0 over 1 is 0. The ratio is 0. All right, what about the secant of 19 pi's over 6? Well, where does 19 pi over 6 land? Well, get your anchors. Here's pi, here's 2 pi. In the world of pi over 6, that is 6 pi over 6, and then that would be 12 pi's over 6. So I must be going more than one rotation for 19 pi over 6. So every 6 pi's over 6 gets you halfway around. So if I went all the way around, I'm at 12 pi's over 6. Well, I'm trying to get 19 pi's over 6, 19 30-degree angles, right? So now I'm going to keep going. If I go all the way to here, that would be 6 more. That's 18 pi over 6. Well, I need 19, so I got to go one more. 19 would fall in the quadrant right after him. So that is 19 pi's over 6. Well, obviously 19 pi's over 6 won't fit in a right triangle, but the reference angle will. And the reference angle is 1 pi over 6. So what you're really being asked to find is the secant of pi over 6, but it landed in quadrant 3. So what is the secant of pi over 6? That's a 30-degree angle. What's the secant of a 30-degree angle? Well, the secant of a 30-degree angle, that's the reciprocal of cosine. So cosine would have been a over h, root 3 over 2. So secant is going to be h over a, 2 over root 3. Then I got to clean that up. And it's actually 2 root 3 over 3. And then what is is it positive or negative? Well, according to all students take, only the tangent function gets you a positive ratio for angles in quadrant 3, which means that the secant, which follows the cosine, would be negative. Because again, The x-coordinate would be negative for an angle that landed in quadrant 3, which means the cosine and the secant would be a negative ratio. Okay. All right, here's some different ones. They just tried to give you, same thing, you're still going to have to find these exact values. They're just giving them to you in like a little expression. So just handle them one part of the expression at a time. All right, so they've asked you to find the exact value, which means you shouldn't be using a calculator. So they want to know what is the sine of pi over 4 times the cosine of pi and then minus the sine of 3 pi over 2. Well, remember, the answer to this is a ratio. The answer to this is a ratio. The answer to this is a ratio. And then they want you to multiply and subtract all those ratios together. All right, what's the sine of pi over 4? Well, guys, go to your special right triangle. What's the sine of a 45? O over h is 1 over root 2. 1 over root 2 becomes root 2 over 2 when I clean it up. So that is root 2 over 2. And pi over 4 landed in quadrant 1. So the answer is positive. All angles that land in quadrant 1 have positive ratios. So that would be positive root 2 over 2. Now I have to multiply that with the cosine of pi. Well, what's the cosine of pi? Where do pi radians land? Right there. That's pi radians. So that would be the point -1, 0. So the cosine of pi is the x-coordinate, which is -1. And then I have to subtract the sine of 3 pi over 2. Well, where does 3 pi over 2 land? 3 pi over 2, 3 90-degree angles, goes all the way to there. There's 3 pi over 2. So what ordered pair is that on the unit circle? That's down 1, so that's 0, -1. The sine is the y-coordinate, so that would be -1. All right, let's do it. So what's root 2 over 2 times -1? That's negative root 2 over 2. If I subtract a -1, it turns into +1. So that's your answer, this expression. We can clean it up a little bit by getting a common denominator and physically adding these two numbers together. So if I get over 1 and I get a common denominator of 2, that's going to be negative root 2 over 2 plus 2 over 2, right? Times both by 2. And then you get negative root 2 plus 2 all over a common denominator of 2. Okay? All right. What is the secant of pi over 4 squared plus the cosecant of pi over 2? Well, the secant of pi over 4 is the secant of a 45-degree angle. So the secant of a 45-degree angle, well, remember, a 45, the secant is the reciprocal of cosine. So cosine would have been a over h, 1 over root 2. So secant is h over a, root 2 over 1. So that's root 2. And it's positive because 45 is an angle in quadrant 1. And all trig functions get you positive ratios for angles in quadrant 1. So that would be root 2 quantity squared plus, now they want the cosecant of pi over 2. Well, pi over 2 is 90. So at 90 degrees, what ordered pair are we working with? Well, that's up 1, that's the point 0, 1. So if they ask for the cosecant, that's the reciprocal of sine. The sine would have been the y-coordinate. So the cosecant is the reciprocal of that y-coordinate. But the reciprocal of 1 is 1. So the answer is 1. So root 2 squared is actually, 2. And then we have to add 1, and the answer is 3. So they're just going to ask you this in like an expression form, but it's still all about being able to find the trig functions of these special angles and getting all of those special ratios. All right, look at this one. Watch out for keywords, all right? Think about what you know now. It says find the values of sine t, cosine t, tangent t, cosecant t, secant t, cosine t, if p is a point following this ordered pair, is the point on the unit circle. Notice they're telling you that this point is on the unit circle. That corresponds to the real number t. Well, they're calling this the real number t because when you measure an angle in radians, you are measuring it as a real number. So when they talk about the real number t, they are talking about an angle, but they can call him a real number because he must be measured in radians. All right, well, let's set this up. Let's get a little perspective. They're telling you that this point is a point on the unit circle that corresponds to this angle. All right, so get yourself, the bigger I make this, the easier it probably is, a unit circle. Okay, and this angle T corresponds to this ordered pair. So this ordered pair is negative, negative. So he must be in quadrant 3. All right, so that is a point on the unit circle that corresponds to this angle. So that means that your angle rotated all the way to there and intersects the unit circle at that point, which they said is negative root 3 over 2, comma, negative 1/2. Okay, so really this is angle T, but it's actually his reference angle that we use to fit inside of the right triangle. And since his reference angle and the real angle share this terminal side, they share this ordered pair, which means their cosines and sines are going to be the same. Okay, so now you shouldn't have to make this any harder than it is. You shouldn't even need that picture. I just wanted to give you perspective, even if you wanted to label this picture now. Well, think about it. This is a point on the unit circle. So really, this distance right here from here to here has to be represented by x. So that's negative root 3 over 2. This distance from here to here has to be his y coordinate, negative 1/2. And since this is on the unit circle, we know the radius is 1. So if you want to draw that picture, you can, but it should be easier than that. The minute they tell you that this point is on the unit circle, well then what do you know the x-coordinate is? The x-coordinate is the cosine of that angle T. The y-coordinate is the sine of that angle T. So you should be able to find all of these ratios without even drawing this. You should just be able to use x is cosine, sine is the y-coordinate, and start writing down your ratios. So if I do that, that means that the sine of angle T should be his y-coordinate, which is negative 1/2. Or think about it, even if you use your picture, the sine of this angle T is going to be O over H, the y-coordinate over the radius. So what is negative 1/2 over 1? It's negative 1/2. But you shouldn't have to do that. You should just be able to use the ordered pair. All right, the cosine of angle T is the x-coordinate, which is negative root 3 over 2. The tangent of angle T, now remember, tangent doesn't appear on the unit circle, but we can always build them by putting the y-coordinate over the x-coordinate. Or, go to your picture, it would be the opposite over the adjacent, or the y-coordinate over the x-coordinate. So it would be negative 1/2 over negative root 3 over 2. And then obviously we have to clean that up. So I'm going to times by, well, a negative over a negative is positive, and then I'll times by his reciprocal to get rid of them. All right, and then my 2's cancel, and I'm left with 1 over root 3, and again, it's positive because it's negative over a negative. All right, and then I clean that up, and it's root 3 over 3 is the tangent of that angle T. All right, and then the reciprocals is, now you can just take the reciprocals of these ratios that you already have. So the cosecant of angle T is the reciprocal of sine, so that would be negative 2. The secant of angle T is the reciprocal of cosine, so that would be negative 2 over root 3. And then I'll clean that up, and it's negative 2 root 3 over 3. Okay, and then the last one, the cotangent of angle T is the reciprocal of tangent, so it would be 3 over root 3. I'll clean that up. You get 3 root 3 over 3. My 3's cancel, and it's just root 3. Okay? All right, perfect. All right, I just have a couple more angles, ones to practice with you. And again, because this point is a point on the unit circle, like I said, the x-coordinate is cosine, the y-coordinate is sine. And since you can recognize these ratios, these are special ratios, right? So obviously this angle was some multiple of 30, 60, 45, obviously because of those ratios that we're working with. But they can ask you that exact same question even if you don't recognize the ordered pair. look what it says. Find the values of sine t, cosine t, tangent t, cosecant t, secant t, cotangent t, if this point is the point on the unit circle. The minute they mention the unit circle, you automatically know if he's a point on it, then the x-coordinate is the cosine of the angle. The y-coordinate is the sine of this angle. You shouldn't even have to draw a picture. You should automatically know that these x's and y's represent a cosine and a sine. All right, it is the point on the unit circle that corresponds to the real number t. And again, the real number t is an angle. They're measuring it in radians, so they can call it a real number. So again, if you wanted to draw a picture, give yourself a unit circle. Mine's terrible. All right. And then that is a point on the unit circle. It's positive, negative, so it must be in quadrant 4. So here's an angle that would have landed in quadrant 4 with that ordered pair, root 5 over 3, comma, negative 2/3. So obviously the real angle T is not fitting inside a right triangle, but his reference angle will. So it's his reference angle that we use to fit inside of that right triangle. And again, since the real angle and the reference angle share this side, they both pass through that point, which means they have the same cosine and sine ratios. All right, well again, if you wanted to label this, this would be, right here would be root 5 over 3. This would be negative 2/3, and then the radius is 1 on the unit circle. But you shouldn't need to do that. The minute they tell you this is on the unit circle, you know that the x-coordinate is the cosine and the sine is the y-coordinate. So you could start doing sine t is, well, the sine is the y-coordinate, negative 2/3. Or if you looked at this triangle now, O over h, oh my God, sorry, I didn't do that. O over h is negative 2/3 over 1, or a y-coordinate over a radius is negative 2/3 over 1. All right, the cosine of angle T is the x-coordinate, so that's positive root 5 over 3. The tangent of angle T is, well, tangent is y over x, right? You come over here, you could do O over A, or you could do y over x. So y over x is negative 2/3 over root 5 over 3. So a negative over a positive will stay negative. Let me just clean this up. Times by his reciprocal. Gone, gone. You get negative 2 over root 5. If I clean that up, I get negative 2 root 5 over 5. Okay? Well, the cosecant of angle T is the reciprocal of sine. So that'll be negative 3/2. The secant of angle T is the reciprocal of cosine. So that'll be 3 over root 5. Clean that up. And you get 3 root 5 over 5. All right, and then the last one, the cotangent of T is the reciprocal of sine. So the oh my God, it's the reciprocal of tangent. So the tangent, before we cleaned them up, where am I, was this, negative 2 over root 5. So I'm just gonna flip that over, and it's root 5 over negative 2, because that's easier than flipping this one over and having to clean it up. Okay, all right. And then my last example is, now I just want to warn you that now students, you could represent this. And again, since this was a point on the unit circle, we knew his x and y coordinates represented the cosine and the sine. But if you notice, those are not our normal ratios. That just means that this angle is definitely not a multiple of a 30, a 60, or 45. He's just some random angle that isn't one of our special angles. All right, last one. All right. If negative 3, 4 is a point on the terminal side of an angle in standard position, find the exact values of this. Well, notice, now they've given you a question that's kind of similar to what we've done, but they didn't mention the unit circle. This is just a point that an angle passes through. So since they have not mentioned the unit circle, you can't assume that the x is the cosine and the y is the sine. They have not mentioned the unit circle, so you cannot assume that that's what that means. So you're going to have to draw this one out. So just give yourself a coordinate plane. All right, this point is on the terminal side of an angle. So give yourself an angle that passes through that point. Well, negative 3, 4 is right there. So give yourself an angle that passes through the point negative 3, 4. Okay? Oh, sorry. Give yourself an angle. That's an angle that passes through the point negative 3, 4. So you're going to have to construct a right triangle. If we're going to find all of these ratios, we need a right triangle. So clearly the original angle doesn't fit in the right triangle, but his reference angle will. So if you construct a right triangle, now just label your sides. From here to here would have been the x-coordinate, so that's negative 3. From here to here would have been the y-coordinate, so that's... Oh, guys, I drew it in the wrong quadrant. Hold on. Sorry, negative 3, 4. Give me 1 second. Negative 3, 4 would be in quadrant 2. So negative 3, positive 4. So here's an angle that passes through that point. That's the point negative 3, 4. My bad. All right. Okay. So obviously this angle won't fit in a right triangle, but his reference angle will. So construct a right triangle. So from here to here would be negative 3. From here to here would be positive 4. And then to find the hypotenuse, which would be the radius of some circle, but remember, this isn't the unit circle, so we can't assume it's 1. So a little a squared plus b squared equals c squared. Then 9 plus 16 is 25, the square root of it, that